The lesson outcome for this video is I can solve a system of equations by graphing. Of course, before we start graphing a system, we should probably know what a system is. A system of equations is two or more equations that use the same variables. In this unit, we will only use two equations, but it is true that if there are more equations, that would still work. So this right here is an example of a system of equations. We've got negative x plus 2y equals 3 and 2x plus y equals 4. It's two different equations, and they use the same variables, x and y. Now, what that means is if we're trying to find the solution or the answer to a system of equations, we would need not just x and y that make this equation true, but the x and y value would also have to make the other equation true. So a solution to a system is an ordered pair, remember that's like this, an x and a y coordinate, that is a solution to both equations. So we're going to look at a little practice on the next page of how we can see if a coordinate pair is a solution to a system. Okay, so here is that same system from the previous page. Negative x plus 2y equals 3 and 2x plus y equals 4. The question here is to tell whether the ordered pairs that are listed below are solutions to the system or not. All right, so remember that. This is our x coordinate in our ordered pair, and this is our y coordinate. So what we're going to do is we're going to put 2 in for x and 5 in for y in both equations, and it has to be true for both of them to be a solution. So, for our first one, negative x, now x is 2, right? So let's back up one quick second here. Let's, sorry about that. Let's just get rid of this for a second, and I can't. Okay, so I'm going to rewrite my equation first, which is why I kind of paused. So let's rewrite this first equation, negative x plus 2y equals 3. Now our job is to take the 2 and put it in for x and the 5 and put it in for y. All right, so we're going to go ahead and write negative 2, because x is 2, plus 2 times the y value, which is 5, equals 3. We're trying to find out if this is true or false. We're wondering. All right, so this is negative 2 plus 2 times 5 is 10. And the question is, does that equal 3? And then negative 2 plus 10 is 8 equals 3. Does 8 equal 3? No. All right, 8 does not equal 3. So we know that 2, 5, this point, is not a solution to this equation. Now, if it's not a solution to this equation, it doesn't even matter if it's a solution to this equation, because it must be a solution to both equations to be a solution to the system of equations. So I'm not even going to take the time down here to check our other equation, because it doesn't matter. All right, let's try the next one then. Again, we have negative x plus 2y equals 3, and we're going to put negative 5 in for x, right? And negative 1 in for y. So we get negative, negative 5. Notice, be very careful there. It starts with a negative, and then we need a negative 5. So negative, negative 5, which we will simplify to positive 5 in a minute, plus 2 times the y value, which is negative 1, equals 3. And again, our question is this equal? So negative, negative 5 is positive 5. Plus 2 times negative 1 is negative 2 equals 3. And 5 plus negative 2, when we do this math right here, we find out that that is 3. And then the question is, does 3 equal 3? Well, yes, it does. So far we know that negative 5, negative 1, this point, is a solution to this equation. Now we need to find out if it's a solution to the second equation. All right, so the other equation is 2x plus y equals 4. Now we're going to put in negative 5 for x and negative 1 for y in this equation. So 2 times negative 5 plus y, which is negative 1, equals 4. 2 times negative 5 is negative 10 plus negative 1. And the question is, are these equal? As you can tell, they're not going to be. Negative 10 plus negative 1 is negative 11. And negative 11 plus negative 11 equals 4 is false. That's no, not true. So no, the answer to the question, negative 5, negative 1 is not a solution to this system because it's only true for one equation and not the other one. Okay, so the third one over here, 1 comma 2. Again, we're going to check to see if this is a solution to both equations. I'm going to put 1 in for x and 2 in for... Okay, so we put negative x, and x is 1, plus 2 times the y value, which is 2, equals 3. Negative 1 plus 2 times 2 is 4, equals 3. And negative 1 plus 4 is 3. And so 3 does equal 3. So yes, this works. Again, let's try our second equation. We've got 2x plus y equals 4. I'll put a 1 in for x. Put a 2 in for y. 2 times 1 is 2. 2 plus 2. 2 plus 2 is 4, and 4 does equal 4, so this is true again, which means that 1 comma 2 is a solution to the system. Okay, so the topic again of this lesson is to solve a system by graphing. So what we're going to do is we're going to use those graphing skills we've been using all year, and we're going to graph our two equations, and then we're going to find the solution. Now, as it says above at the top, when graphing, if the lines intersect, which again means cross, if they intersect or cross, at a single point, then the coordinates of that point are the solution to the system, because that will be the one location that is true for both equations. All right, let's give this a try. So the first one, y equals negative x plus 1. So y equals negative x plus 1 needs to be graphed carefully on this coordinate plane. Remember, we've been working on this. The negative 1 right here is our slope, so m equals negative 1. And then our b is over here, and b is 1. So if b is 1, we begin on the y-axis at 1, that's right here. And we're going to move using our slope, which is negative 1 or negative 1 over 1. So we're going to go down 1, right 1. And that point is right here. All right, and then to draw this line, we want to draw it really, really carefully. I don't think that it's going to work for me to use a ruler on my iPad as I'm recording this. Let's see here. I'll pause this for 1 sec. Let's see. All right, so that's pretty good. Hopefully that'll work out for us. Okay, and now we're going to graph the second line. So we've got y equals 2x minus 5. Our slope is 2, the number in front of x, the coefficient of x, and our y-intercept is negative 5. So b is negative 5. Notice both of these equations were in slope-intercept form. So we're going to begin at negative 5. That's right here. And we're going to move using our slope of 2, so up 2 and right 1. Up 2, right 1 is right here. And up 2, right 1 is right here. Again, if I put 2 of them on there. All right, so now we're going to draw our other line. It's a little bit off. We're going to use a ruler in class. And what we see here is that our lines do intersect or cross. And that means that the coordinates, so I'll kind of highlight this up here, the coordinates of that point is the solution to the system. So the solution to this system will be this point right here, which is at 2, negative 1. That is the point that is true for both equations. Now, if we wanted to, we could check this solution in both equations to make sure it works. For time's sake, we'll talk about that more in class, but that is what we would want to do to make sure that things are correct. All right, now this example is solve the system by graphing, but our equations are in standard form. When our equations are in standard form, that is when we use the teeny tiny table to graph them. So we have negative x plus y equals 5. We want to graph that, using the teeny tiny table. And our second one is 2x plus y equals 8. And we want to use the teeny tiny table to graph that one as well. So in the first one, I'm going to put a 0 in for x. When I put a 0 in for x right here, that becomes 0, and we get y equals 5. So y equals 5. And then if we put a 0 in, let's get rid of this. If we put a 0 in for y, right here, what we get is negative x equals 5. So be careful with that. We're going to write negative x equals 5, which means we're going to divide by negative 1 on both sides. So x equals negative 5 for our x-intercept. And we can graph those 2 points. So 0, 5 is on the y-axis right here, and negative 5, 0 is on the x-axis right here. Now when we graph this line, I'm going to see what I can do with my line options here. When we graph a line, we are going to see something like this. Alright, pretty good. Whoop. Okay, now we need to graph our second line. When we do that, we're going to use our teeny tiny table again. So put a 0 in for x right here. That becomes 0, so y will be 8. And again, use the skills you've learned in previous chapters. And now we're going to go ahead and put a 0 in for y right here. So we're going to have 2x equals 8. And again, 2x equals 8 means that x equals 4 when we divide both sides by 2. So we're going to plot those points. 0, 8 is right here. And then 4, 0 is right here. And now I need to draw that line. Okay, let's see if we can get that one in here. Alright, I guess it's orange. Alright, and we're going to try and fix this to be a little bit more in line with those points. There we go. Now remember, a solution to a system of equations is where they intersect. So right here is where these two lines intersect, and it looks like that point is right here at 1, 6. So 1, 6 is our solution. Notice we went over 1 on the x-axis and up 6 to get to that point. So 1, 6. And again, we'll talk more about checking those in class.